You're on mute.
Okay, so I wasn't recording, so I started the recording of the class. So when I'm done, I think I'll put it on Zoom. Not Zoom, put it in an announcement or something. I'll post the link. All right. So I was saying if you don't have any question, I'm gonna move on to what else is on the quiz. So this is one of the quiz questions, right? You got to substitute. And yeah, think about substituting something as like in this one also, right? What order of operation matters. This is the next thing that's on the exam was to do distributive property. Um, let's do what distributive property is. So distributive property, can you see this when I write right here? Can you see this? Is this on screen or no?
Yes.
Yes.
No. Okay, thank you. So the distributive property, it's make sure I know letter. A times B plus C, or even D, whatever. However many terms, like the addition, separate each term. The addition or subtraction. Whenever we distribute, whatever is outside get multiplied twice. Get multiplied by this number, get multiplied by that number. And the new number becomes A times B plus or minus A times C. So that's what they say. A gets distributed to both terms. A gets distributed to both terms. So let's do this problem. So I'm going to show you the common mistake. When you do this problem, you go 5 times 7. So you're going to say 35. And 35 what? The y is just there for the ride. 35y. Plus, the common mistake people put 2 and just keep it pushing. That's a common mistake. And you're wrong because you didn't distribute. The 5 didn't get distributed. This will be a wrong answer. The 2 must be multiplied by 5. Let me get rid of that 2. The 2 must be 5 times 2, which is 10. That is the correct answer. I guarantee in the multiple choice, you will see 35y plus 2. You will see 35y plus 2 be one of them probably number letter A, choice A, because they know it's they call it one of them glaring wrong answer errors. All right. I'll do another one. This is the one similar to what's on my quiz because you got to understand to distribute negative. You got to understand how to distribute negative. -3 times a +2. Because remember, the negative says everything here got opposite sign. You better remember that. A lot of people forget to change the sign. -3 times 2, I get -6x squared plus -3 times 5. That's 15 minus 15. In fact, let me make a correction right here. Instead of plus, because I saw this plus right here, but I got to say negative. The number in front, the sign in front of the number is very important. The sign in front, whether addition or subtract, is the sign of the number. The sign in front, whether plus or minus, is the sign of this number. So if you see a minus, don't say, oh, it's a minus, it's not a negative. It means it is a -5. It's plus a -5. But they won't put plus -5. They're just going to say -5. So I'm going to change this back. I will change this back to -15x And one more time, negative times a positive is a negative. 3 times 1 is 3. That will be the solution. That's distributive property. I have one question similar to that, maybe two. All right. If we're not distributing, we're combining like terms. These are what we need when we simplify. On the test, the student was upset saying I didn't tell him to distribute. It won't say distribute. It's going to say simplify this expression. It will say simplify the expression. You have to know that the rule is I'm distributing the number outside to all the terms. Right? I'm distributing this number outside to each term. Any questions? Okay. So I take it your silence that you understand. We're good to go. Let's scroll. I'm gonna clear the screen. And the next, if we're not distributing when we simplify an expression, the next thing we'll be doing is to combine like term. So we either distributing or combining like term, or you're going to be, most of these problems will have a combination of both. That's what the multi-step equation is having. Multi-step equation, you will have to distribute and combine like terms. So I have a question like the first one on the quiz. All right. Combining like terms is same variable, and the same variable got to have the same power. So x squared is not the same as x, it's the same as x squared. X is different. X is the same as x. And the constant term is the same. So each are different terms because of the variable. Because of the variable, each of these are different terms. So look at the first. Combining like terms, I would combine 3a with, and you got to consider the term. If you say 3a with 4a, you're wrong. That's what a lot of people say. Oh, I see 3a and 4a. You can't see 4a without seeing the sign in front of 4. It's important. You got to do 3a minus 4a. And then we're going to see plus 2b. Again, the sign in front goes with the number, or the number goes with what the sign in front of it. Plus 9b. So you have to be able to do this. This becomes an order of operation, not order, but a sign rule where you got to know how to add and subtract sign. 3 minus 4a is minus a, or 1a, whichever you want to say, plus 2b plus 9b is 11b. 2b's plus 11b. 2b plus 9b is 11. So the answer is negative ab plus 11. That's you combining like terms. And even this one I was talking about, the like terms here, x squared is not the same as xy squared. Y squared here, x is squared here. These are different terms. Even though they got x and y, they are not the same term. 5 will gather with this 4 because it has the x squared y, while 3 xy squared will gather with negative 2xy squared. So that's the type of problem is on the exam. We have to know how to group combine like term. This would be 9x squared y doesn't matter. No, order doesn't matter. Order doesn't matter. I was just about to say that. Correct. This is equivalent to saying 11b, if you feel comfortable, minus a. Some people even put the letter 1a. I don't care. If I didn't put all of that in my system, but when I do go, I will make the correction in the adjustments. So if you put it in and I don't have it in that form, but it is correct, I will make the adjustments. So don't worry too much about your syntax. Just make sure you try to put the right numbers in the answers in. This one will be minus 3y and minus 3xy squared and minus 2xy squared is a minus 5xy. Minus 5. Minus 3 and minus 2 is minus 5. So that's where I say the sign rule matters. Minus 3, minus 5. See, I don't even worry about what's coming. I really care about the number in front. But of course, the variable matters because that's what made the term. So I have to put it back. It's not 3 and 5. It's 3 of something. It's not 3 and negative 2. It's negative 3 of something and negative 2 of something. So I have to put that negative 5 of that something. Couldn't just put negative 5. A lot of students did it on the quiz earlier, and I can't correct it. They're like, oh, but I got it. But, they'll write the answer in such manner. And I can't give you the right answer because you left out the variable. I'm like, I think you got the right idea, but the variable matters. So unfortunately, I couldn't give them credit. All right, that's these 3 different problems kind of worked out. Actually, I didn't do this one. Are we good? Any questions?
No.
Thank you. That
No
feedback.
questions. Thank you.
Let's keep rolling. So those are 2 questions from the quiz. Next, this is the hard one. No, not really, but this is the one that's on the quiz also, the one on top. You'll have to combine. This is a combination of both. So you have to use distributive property and then you're going to combine like terms. So you're doing both steps. So first step, I'm going to say 2 times A, going to give me 6A. Make the letters 6A. 6A, and then I'm gonna go 2 times negative B is negative 2B. Negative 2B. Then this you have to remember outside, we're done. This, we're done with the first term. And if you look, this is really 2 term. This is a one number. This is a multiplier. So it's really one number, and this is the only thing that separates them. Order of operation, that's why we multiplied first. Order of operation, we multiplied before we could add or do anything. So don't take away 2 from 7, and I don't know what you're going to get because these are not the same. Only if they were the same, I could have taken away 2 from 7, and I haven't given anything that looks like that. So your job is to distribute first. Negative 7 times negative 2 is positive 14, and the letter is there, the term follows. So positive 14A. Plus, or maybe minus, who knows? We're going to see negative 7 times positive 3. Negative times positive is a negative. 7 times 3 is 21B. Because it's not 3, it's 3 B's. So if I have 7, it's going to be negative 21B. That's it. Now we group like terms. We group the like terms. What's the like terms? So my like term is, don't forget to mute. And
You didn't like the way I talked to you? You had every ability.
okay. 6A plus 14A, that's the like terms. The B's are different automatically. It's like apples and bananas. So I got 6 bananas and I got 21, but somehow I took away 2 and they took away 21 B's. So if I rewrite this, I really don't do this. I do this in my mind, but you can write it out if you choose. A plus 14A. And right there you see that's 20. 6 plus 14 is 28. I would just write 20A from jump. From the moment I put this to here, I'm doing 20A. Then I'll subtract. We're going to do minus 2. Let me use a different color. Say the black is going to overcome. But minus 2B minus 21. So I'm terrible. I'll make sure I get a tablet pen tool. I'm sorry, I'm using my mouse, right? So this will give me a minus. Minus and a minus is a minus 23B. Final answer. So final answer is, I'm gonna rewrite the answer because I don't like how it looks. Is 20A minus 23B for this top one. Because there's only 2 different terms there, right? How it looks. Because once I simplify it, I'm left with only A and B. So that's how we keep it. Okay. All right. So that's on the quiz. It's on the quiz in another way. I'm gonna show you it's on the quiz in a word problem where you have to be mindful of the sign. So I'll show you that from the homework question. So this is, I think I only have one of these, but with the word problem, it's 2 of them you'll have to know how to do. There. Right, so I'm gonna keep moving if there's no question. So again, that's distributive property, but this one combined in the like term. You had to distribute and then combine the like term. That's reality. That's what most of these problems will look like. And that's what gives it the multi-steps. Because you have to do a lot of these mediocre or in-between interim steps before you get to solving the equation. Which, as I say, is coming for next week. I want to schedule. I hope the quiz by 6:30 will 6:45 the latest, which the quiz, and then you'll get a half hour for the quiz, and then after that you get your half-hour break. So when I say start the quiz, then you get a half hour to take the quiz, and then after that you come back, and I say maybe a half hour right after, so maybe an hour and maybe another hour and 10 minutes, 15 minutes, give or take. Keep rolling. Again, this is the same type of problem. Oh, is this a solution? I didn't quite ask these questions. I didn't ask for you to check anything, but I do ask for substitution. So this is really a substitution question, but they set it up in like a yes or no format. Is this a solution? But you have to substitute and see. And yes, it is a solution if I test it, but I didn't have a question. Yeah. Here's the questions I had. Was these two-step equation I had. So solve this, and you notice it didn't say solve, but the difference between this equation And these are, look at this, there's no equal sign. So when student was doing this and giving me an equal sign, like if you give me a number, you're wrong. There's no way you can give me a number because I don't ask for a statement. If you give me a number, the number will make the statement true. What number is going to make this true? It's no, it just could give any random number. So these are not numbered. These are, as I say, we're simplifying term. We're grouping like term and we're left with the variables still. It's just in a simplified version of this. It's in a simplified version. Then, because if like if I had numbers substitute, and I rather substitute in numbers into the simplified version than this original. That's how you really think of it. I want to substitute numbers in. I want the simplest version to substitute numbers in. That being said, that will clear. Let me find the word problem. I'm gonna find the word problem now so it don't become confusing. Students had issues with it. I was almost at a big fight about it. Nah. Where is this problem? Well, the question is right in that corner. All right. So a question like that I did ask. I'm gonna go over it. So I'm gonna keep getting size that. Okay. So there you go, something like that. Nothing like that. Nothing like that. No multi-step solution, but of course that is I'll talk about those. What is it? This number one. All right. After I'll go over these. So I'm not sure where. But I did keep the question on, but I just want to make sure you guys see it because I'm not taking it off. It's a legitimate question and it's not the next level question, but it was a word problem. This one. This is the same combined and like term, but I didn't say it was. So you got an advantage than the students today because they say I didn't let them know. I did talk about it. I always have these problems. These are tricky questions. And the way I say that, think if they say subtract um 5, subtract 5 from 8, subtract 5 from 8. To subtract 5 from 8, you're gonna write 8 minus 5. That's important. That's important. This setup is important because a lot of people want to put, oh, because they saw the 5 first. Subtract 5 from 8. They want to set it up as in this fashion, but this would be wrong, right? This would be wrong. You have to understand the question. If I'm taking something from something, I'm taking out the smaller thing. So 5 from 8 will give me 3. That being said, for this question, Again, this is a test question. First question. I want to subtract 7x minus 2. And I'm going to take that away from 3x minus 5. I want to take that away from it. See, like the 5 from the 8, not this way. Because a lot of people going to want to put it in front. A lot of people going to put 3x minus 6. Also, this is wrong. Why this is wrong? I don't like the read because I didn't distribute. This not really supposed to look like that. This is supposed to look like this. This is the appropriate way. Take away the first number from that second number. That's how you're supposed to line it up. And then in doing that, we can group the like terms. In doing so, we can group, well, we'll distribute first. Look, right here is a positive 1. It's just a positive 1. Nothing is in front. So to get rid of the parentheses, positive 1 times 7 is just 7. 1 times anything is just 7. Positive 1 times 2, look, is just negative 2. That's why they don't give this. Nothing changed. Look at the inside and look at what came out. Nothing changed. If you see this, you're very rare going to see this in the algebra class. Very rare they're going to put just no number in front. They're going to put a negative in front. Get ready to do some work. You got to remember this negative will change every sign inside. That becomes negative 3x. And here's where people make a lot of mistake. They put minus 5. Minus 5 is incorrect. Minus 5 is incorrect. Why is minus 5 incorrect? Why?
Because you have to distribute.
Negative and a negative is positive.
Excellent, both of you. It needs to be distribute, and when we distribute, we see negative times a negative. This is supposed to be a positive. So if you put a mistake and put negative 5, you're already in the wrong, and it's no recovery. Well, I don't know. I doubt you're gonna recover. You got to make sure you make the right steps. So that's the first we did. We had to distribute. First, actually, you had to dissect the problem, right? So you had to know how to set it up in this fashion. That's what put the complexity to this question. It's the hardest problem on the quiz today, right? The complexity, I have to know, I'm taking away this number from this number. So this numbers go first. This is the first number. And then put it in parentheses to make sure I don't miss the sign, because this minus tell me the opposite of everything inside of the parentheses. I need the opposite of everything in the parentheses. So the opposite of positive 3x is negative 3x. The opposite of negative 5 is positive 5. That's what the negative outside says. And I'm telling you, a part of algebra, every time you see these parentheses, your job is to look in front. Is the number in front of my parentheses negative? Because if that's negative, all the signs will change. And I'm telling you, at this level, they don't have no other trick. It's coming. What else I'm going to tell you when I tell you the group like term? So that's why sign rule is important. So now I'm a group like term. I see 7x. Use a different color. So I see 7x. And I see minus 3x. So 7x minus 3x is a 4x. And minus 2x plus 5. Minus 2x plus 5 is like 5 plus negative 2. I'm going to write the group and I'm going to show. So I did 7x minus 3x. Then I did minus 2 plus 5. This, if you can't see, you can put, and these you can put in the calculator. You don't put the x's, but I could put the numbers because they like terms. It doesn't matter. Whatever it is coming back. So 7 minus 3 is 4, but 4 what? It's 4 of something. It's 4x. I'm bringing the x with it. And in this case, 2 minus 5, 2 plus 5, minus 2 plus 5 is the same as 5 plus 5 minus 2 because of commutative property. And this, you know, it's 3. But like I said, you don't have to play around with arithmetic. You could put that in the calculator. If you're not good at signs, once you set it up, use your calculator. So this is on the quiz. Got to set it up, got to distribute, got to group like term, and put the simplified version. And grouping the like terms, you have to understand signs. We go back to the all right, going through. So yeah, this is where I said this is the hardest your solving will get. I didn't ask you to solve anything beyond a two-step equation. Solving a two-step equation meaning I have to do the first step, which is I want to take away 5, meaning that I want to get rid of the -5, and I need opposite inverse operation, they call it. So because this is a takeaway, I'm going to add 5 because I want it to be 0. I want it to be 3x plus 0. So I want to get rid of -5. So I'm going to add 5. And when I add 5, it makes it 0. What I do on one side of the equation, I do on the other. Imagine you on a seesaw, you got the balanced weight, so you sit in the middle and you put weight on one side. The other side is going to go up unless you put the same weight on the other side for it to be equal again. Whatever I do to one side, I must do to the other side of the equation. That's one of the rules of equality. I'm gonna use this other color. So this purple is the main. They call it equivalent equation. So this purple is a new equation, 3x plus 21, but is equivalent to 3x minus 5 equals 16. Why I say it's equivalent? The same answer for this x will be the same answer for that one. So they look different. They are different, but they are similar. Because one just happened. I took one step out of the problem. So this is just a one step that's left. And we don't want 3 x's, we want 1 x. Because we want 1 x, we'll divide away the 3. What I do on one side, because now I got 1 x. This cancel out. 3 cancel 3, makes it 1 x. I got to do it on the same side. And now my final answer, x, is equal to 7. So all these are equivalent equation, they say. What do I mean? Because if I plug in the solution, 7 equals 7, it's true. If I go up here, 3 times 7 equals to 21, it's also true. And if I go all the way up here, 3 times 7 is 21 minus 5. 21 minus 5 is 16. This also is true. 7 satisfy all these equations. They are equivalent equations. They're not the same, but they have a relationship, right? 7 make them all true. These are all different statements. But this is what we do to solve. We're stripping it down to where we find an isolated x, not negative x, not 2x, not a half of x. We want 1x. All right, let's do this other problem. This is not too bad. This is, all right, so question is this. This is a one-step problem. I'm going to take away the 5 to make x plus 0. What I do on one side, I do on the other side. So the next would be, on this side would be x plus 0. I'm not going to write the 0. X plus 0 on the right. 5 minus 5 is 0. And then 2 minus 5 is minus 3. I like to lead with my variable on the left, so I'm going to rewrite this as x. is equal to minus 3. That can be done. That's the rule of equality again. If A equals to B, then B equals to A. It can go either way. If that's true, then that's true. Question? Any question? The one I
No.
the
Can
one I
you do the fraction? Well, I understand how to do those, but the ones with the fractions trip me up. Like the one to the right.
it won't be there, but I'm gonna tell you how to do these. They say the quickest, we canceling out. We want to make it 1 times x. So no trick. Well, all of these are multiplied by the flip. So see, these step is like we always add or we're going to subtract the first step. We either add or subtract, and then the next step we're going to divide or we're going to multiply. This could be 2-step, but we're going to do it in 1. 4/3. Whenever you have fraction, they say multiply by the reciprocal, the flip of the number. And it's just a trick. It's a trick way to cancel out the fraction. What I do on one side, of course, I got to do on the other side of the equation. So what I do over there, I'm going to put 4/3. I'm sorry, I shouldn't even do this because it's not on the quiz today. It's not. This cancel 4, cancel 4, 3 cancel 3. That becomes a 1. That makes it a 1x. And I'm just left with the other side, 4/3. That's how x is equal to 4/3. And I'm done x. If it was another number over here, I have to multiply it by the number, but 4 times 1 is 4. So 4/3. That looks like a 4, that doesn't look like a 3. That makes sense? Sorry about that. That's a detour. If you don't pay, if that's okay, that's for next week. Sorry, I was supposed to say no to it. All right.
Some of those ones were on the homework though.
Yeah, a lot of them on the
Yeah.
homework. Don't stress
Yeah.
yourself. I apologize. I didn't design the homework, so I couldn't just give you what I wanted. Yeah, but don't worry. Yeah, I think you could go back and correct. I hope you can. But I was hoping you stick with these and skip those. Like skip that. We can do it, but skip them. Like these, I stopped. That's what we stopped last week. I didn't do any of these. Unfortunately, I have something like this on the test. I thought we went over it and I show you because if it's a 2-step, we could solve these. A couple things that I did use from here, but it's not in the sense. And I had a perimeter question, as in this case. Well, no, not in that case. The simple perimeter. You're given the length and the width, not those. Those are geometry questions. I missed those today, so I don't know if I'll get to them today with you guys. Hopefully I do, and I could post the video. Yeah. So I didn't get to go as far as today that I wanted to. After the quiz, it was a lot of discussion. Okay. Yeah. So these, I put a couple of these called literal equation. I did put them on the quiz. Do your best. I'm gonna do them in the homework and show you from the homework why I put them in there. Because if you do 2-step, you can. However, don't sweat it. Remember I told you some questions I gave credit to everybody because student got it right, but some student were complaining, and it was in the second section. I did speak on it briefly. So a question like this is on the quiz. It looks like a 1-step. -17 minus A equals to 22. So what would be the first step? So
You gotta isolate the A.
excellent. Thank you. So we're going to isolate A by doing what?
Addition. The
Well,
I
17 from
subtracted
the
17 from
17.
22, and that gave me negative A. So then I divided the A, and then that gave me -5 as the answer.
correct. So we need negative, as you say, 17 on both. So you just did inverse operation. You went to this side. So many people say they don't like when I write this part, but it's necessary. For me, like my mind work, like if I just gonna have negative 17, why did I do that? I have to put this bit in. I put it in because I want that whatever number is next to the A to disappear. And how I make it disappear, I make it a 0. 0 is nothing. So 0, and you said it becomes minus A equals to 5. But look at that, something is up because I want to know what A is, not what minus A is. So it's another step that needs to be done. And I heard it was A is equal to -5. This should be done without seamlessly. You should be able to do this without worrying your brain. Because it's a negative number, the only way this is going to be true, I got to put -5 in here. Negative times negative will make it positive. But to soothe yourself, because this is another step, I can either divide by -1 or multiply by -1. Divide by -1, negative cancel negative, what I do to the right. The left, I do to the right. And that's how I get -5. So this answer would be -5, because -5 will make it a 17 minus -5 would be a +5. 17 plus 5 is 22. So -5 goes here. And when we check our answer, it should be correct. So that's one of the questions on the quiz. 2-step. All right, that being said, we've seen all those steps. I didn't put any of these. I'm going to talk to Sue to find out how we can put some of those on. None of these inequalities on it. I don't know how to test them. This is on it. Is this? No, not this. This is no. That's not on it. Oh, man, I missed a couple of things. That's a geometric question. I did that already. This is not on it. Next week, you'll have that. So this is on the quiz. I don't know what to do. I don't know if I should tell you to skip it. I waived it. I did waive these questions. The literal equation, but time is it? Yeah, 6:30. I'll cover it. The main reason it's the same order. I want to solve, this means solve for B. This thing mean if and only if. This is true if and only if B is true. And B can only be true if I could plug it in and get the same number. This is the only B I could put in and I'm gonna get 11. If I put in this B, everything gonna cancel out and become -2A, and then, well, except for the 11. -2A will cancel out and the 11 will be left. Because when we put it in, we're gonna cancel out. The 9 will cancel out. -2A will cancel -2A, and it will be 11 equals to 11. All right. Quickly. I don't know if I should do this. 2A plus 9B. It's on the quiz, and I had to take it off. Students wasn't happy. So you got to solve for B. You got to solve for B. The difference is we're not breaking nothing down. We're going to do the same rules. We're going to isolate the variable. So because we're looking for B, B is our variable. We're going to isolate B. Get rid of 2A on both sides. -2A on both sides. If I simplify, let's clean up this equivalence equation. That means 9B. It's actually 0 plus 9B, but I'm not writing the 0. The first part is 0. 2A minus 2A is 0. We're not writing that. But we're going to write 11 minus 2A because we're leaving the symbol. Because if A was a number, I could have canceled it out. I could have did the math. But A is not a number. So I got to leave it like that. Now I need B. See, that's the first step. I told you the two-step equation, we're going to add and subtract, and then we're going to either divide or multiply. That's the two steps. That's the two steps. So next we're going to divide. I'm going to divide away the 9 because I only want B by itself. Boom. And when I cancel 9, B is equal to 11A, 11 minus 2A over 9. So I have those on. I thought you guys will be able to do it. Again, I got some little pullback from the students, so do your best. Don't stress it too much if you see a problem like that, because it was waived. And I'm gonna have what I do to them, I'll waive for you. That being said, you should know it. Whatever I waive this week, I'm putting on next week. Different numbers. So if I go to this, what else did I put on the quiz? But I think you pretty much got this question. So this is almost like another question for the other side, but it's a substitution question. They gave you the perimeter of the rectangle, the width is this. Next week you'll have to know it. I wouldn't give the formula, but this week, and the formula is already given, so you should know the perimeter of a shape, perimeter of a rectangle. Perimeter means what? Anyone? The distance around the shape. The distance around the shape. And when it comes to rectangle, they give it some different, they say this is the length and this is the width or whatever, or width and length. Either way, it doesn't matter. It's up to you how you want to label it. But in a case like this, they tell me the length is 12. If you remember what a rectangle is, and the width is, actually, it went the other way. The width is 24. The width is 12. And the length is 24. So if this side is 24, what you think this side is? 24.
24.
Right. And if this is 12, this side is?
12.
Right. It's a parallelogram. That's one of the definition of a parallelogram. It has two parallel lines and they are congruent. So these two parallel lines are parallel and congruent. These two parallel lines are parallel and congruent. They are parallelograms. All right. And we just add them up. However, you didn't have to know that. They gave a formula. I left the hint in there. So if we count it up, you're going to get 12 plus 24 is 36. On the other side, 36 and 36 is 72. Here, I got 2 times 24. Let me use a different, I'm going to use the red, bright. So I use 2 times 24 plus 2 times 12. And you look at that, that becomes 12. 2 times 12 is 24. Order of operation matters. 24. And this one becomes 48. 48 plus 24 is 72. So that's on the quiz. I know it's a geometry question, but because I gave you the formula, I felt like it's a substitution question. So you just have to know what the length represent. 24 is the length. And I didn't even have to draw the shape. Just know that 24 is the long side and the width is 12, whatever. The short side is 12. And because it's parallel, you know, this is 12, this is 12, this is 24, this is 24. You could do the math without knowing the formula. If you knew that perimeter is it. So when we do geometry, you have to know about the shapes. Shapes is, they care about the border, the perimeter, what's the distance around it, and the area it covers, what's the area inside. So those formulas are formulas you should memorize. The student was asking me, oh, you're going to have provided. I did provide it, but going forward, they repeat those in problems always. So eventually you'll have to know it if you want to be quick. Don't fight that, just learn it. All right, but not right now. You could plug in. So that's another quiz question. What else? Again, I'm still thinking I'm gonna put those on. That's coming next week. That's coming. No fractions. I have a trick for fractions, so I didn't do it. That's grouping like terms, so I worked it out, but you should be able to do this. The same thing. The like terms are the x's and the y. Again, if I want to substitute, I rather substitute a value into the right side. I rather have to just put in, like they tell me what x and y is. I rather use the right side than to use the left side of this equation. Someone say, oh, x is say -1 and y is 2. I rather put it in the right side than to put it in the left side. So that's why we'll simplify expressions. But this is not a solution. So don't tell me, oh, this equals to 2x, or -2y. No, it can't. It's x and it's y. This is the simplest of it because it's two different terms. It's apples and oranges. It's not, I can't make them one fruit. Well, they are fruits, but they're not the same. Right? Whatever. Let's keep going. So like terms. Again, one of those is on it, but don't worry. Yeah. So these are the ones. And of course, I got some order of operation. Not order of operation, no substitution where you must know order of operation. None of them. And nothing we have to solve in except for those two steps. No tip. Nothing with this is an equation we have to solve. Nothing so you have to solve. Everything is simplified. Something like that. I say the most difficult. And the one that student had the most issues with. I got to get to the geometry question so you see how they can come. But we'll do it later. So that's on the quiz. This one right here, that's weird looking. Gotta do it. This is the one I say tricked up everybody. Make sure you understand that for many people. And I think that's it. We're ready for the quiz. Evaluate again, that just means to substitute -1 into A. -5 minus 3, -8.
So with that one, are we solving it completely or we're
Mhm.
just
This is
plugging it in?
plug it in, but it gives you a number. So whenever you plug in the word evaluate, meaning like find the value
Okay,
when A is -1. So this is an algebraic expression. It's called an algebraic expression. You're going to take that algebraic expression and you're going to substitute whatever the value of A is into
right.
what A is supposed to be. And that will make this -1. Now this is a numeric expression. You went from an algebraic expression to a numeric expression. Algebraic because it has letters, variables, numeric because it's all numbers, and this is what we use arithmetic. For this one, you need your order of operation. That's why order of operation comes, and so it's one of the last topic in numbers, because if you don't know how to do order of operation, you're gonna struggle in algebra. So 5 times -1 is -5 minus 3. -5 minus 3 is -8. And remember, I said, when you get to this stage, you could put this in your calculator if you know how to do it.
Okay,
And it's set up nice because we work from left to right. It's not like they put 3 first and you're going to take away 3 from the 5. It's set up nice. You have to multiply first from left to right. Well, you don't have to, but we do. Okay, so the value, evaluate just means finding the value. And that one you give a number. So even though this expression don't have an equality, it's almost like it did. Because they said, plug this in and tell me what it is. Plug this value in and tell me what it is. It's a variable because I could have said plug in -1, -2. I could have said plug in 0. What happened when x is 0? This is minus 3. That's why I say it varies. When a, not x, when a is 0, this is minus 3. It varies. That's why they leave it as a variable, because we want, no matter what number I put in, I know what the outcome is going to be. They call that a function later on. I know what input is, and I know what the output is going to be. And all that is the same exact thing. Evaluating, later on, they're going to call it a function. And you're finding the value of the function. All right, so, but today, that's it for you. I think that's it. I think everything I went over, all the things you need. Yeah, I think I went over everything you want to need for the quiz today. Oh, this problem I have on the quiz also. Same deal, evaluate. But I like this because it's an order of operation, and it puts some sign rules in there where you have to be careful. So I like that problem for that, because I'm testing your order of operation skill and your sign ability, like how you know how to multiply and add signs. So the way I recommend doing this is that I put a space holder wherever variable is supposed to be. This is b squared. Whatever is b squared is going into there. And that's minus 4. Minus 4a, not a, but 4a, whatever a is supposed to be, and c, whatever c is supposed to be. So I put these space holders because it keeps me safe. I like space holders. Just like I tell you, when you do that subtraction problem, make sure you put the parentheses. It's a way to, I can't memorize everything, and sometimes I can't visualize everything. So I'd rather make my life easy. B, -2 goes here. -2 goes into B. See, B squared is -2. Right? 4 goes A, -1 goes into 4AC. -1 goes here. And 3 is into C. I took this algebraic expression. I substitute the numbers, the values in, and now I have a numeric. This algebraic is now a numeric expression. Still an expression, but I can find the value of numbers. I can't find the values of letters, so I have to let letters stay like this. This is the simplest this can be. Can't break it down. I can't take out 4 A's out of B squared. Can't take out a C out of B squared. Can't. I just got to leave it right there. It stays. I can take out numbers out of numbers over here. That's different. So first I'm going to do exponents. -2 squared is 4. And you better know order of operation, because if you say 4 take away 4 is 0, you're done. If you say 4 take away this 4, you're dead in the water. You got to say -4 times. In fact, I'm going to write out the steps. I'm going to write out the steps right here. -2 times -2. That's where the 4 comes from. And then this side, -4 stays, but -4 is times -1 times 3. Again, we're going to multiply before we add. So over here, I'm going to do 4. Over here, I got to multiply all of these first. -4 times the 1 is a +4. +4 times 3 is a +12. So I'm going to rewrite +12. And the answer look like it's 4 plus 12 is 16. 4 plus 12 is 16. So this is on the quiz. We have to know how to keep the order. Order of operation matters. And yeah, that's it. I think that's it for the quiz question. 16. Check it. So that's one of the problems. And again, I'm picking them because you get to practice your order of operation in the same setting. Okay. So all of those, none of these, but they're coming next week. All right, we're gonna pause and you're gonna get ready to take the quiz. And after the quiz, you're gonna get a half-hour break. So we're gonna come back in an hour. So sounds good?
Yeah.
Yep.
Thank you. Yeah, it's kind of difficult with Zoom. All right, keep forgetting it, you guys are home. So since you're home, I got to give you the code for the test. I'm sorry, I don't know what's going on. I'm showing stuff I don't need to show. Assignments, that's what I need. Um, the quiz. Uh, stop sharing my screen. All right. So I'm gonna type into the chat the passcode. Actually, I'm gonna share my screen with the passcode. So I'm gonna type it. Probably do that. But I want to get to
So for
the software without you seeing the question. Go ahead, you can talk.
question, so for clarification, right after the test, we're going to break.
Yes.
So what time you want us back?
7:40 now. Uh uh let's see, I give you an outfit to give you
It's 6:40, so you saying 7:40, around that 7:40, 7:45?
yeah, maybe 8 o'clock.
Okay, that'll work.
8 o'clock. All right.
Yep.
So okay, so we'll be back at 8 o'clock. All right, let me give you the setup for the exam. Everybody's ready, right? You ready to log in? Make sure you could start the exam. So the password.
Is the review code going to be the same as the password?
No, the river code is quiz 4, something like that. Whatever, quiz 3. This is quiz 3. So this is the pass, the what you call it? The enter code. Uppercase 3. 3 uppercase MVKEX. You all should be able to log in. Once you're logged in,
Wait, are you gonna put it in the chat?
you can't see my screen. I'm sorry. I stopped sharing my screen. I thought I was sharing my screen. My bad. Yeah, let me put it in the chat. Sorry. There you go. That is the passcode. That's for to enter.
We still can't see your screen.
You still can't see.
I know.
Yeah, can't see it.
I stopped sharing my screen. Look at the message I just sent. Look in the chat box, and you'll see that I just put Control Z. This information is in the chat.
I don't see it yet.
Or you see my
I don't
screen?
see it.
You see my screen?
Yeah.
Right here. 3 MVKEX.
What's the review code?
Quiz 3. All lowercase.
I'm sorry. Can you say it because it's so small I can't see it? I know you said 3.
3 uppercase M, lowercase v, uppercase K, uppercase E, lowercase x.
Thank you.
So you gotta let me know too for when I'm working out the stuff if it's too small. Because I'm not sure how you view my screen, okay? That is a factor. So I'm gonna log out and I'm gonna log back in at 8. Or maybe I'm gonna log back in at 7:45-ish and wait for you guys. I won't start the review until everyone is here. I have a few questions that one of them that I did put the wrong answer. I don't know how I messed up, but you're gonna get an answer and it might be right. Don't worry, I'm gonna correct it when I come back. So just do your best and group the like terms. Yeah. Something for syntax, I might, don't worry, do your test and we'll talk after. Right? I'm logging out. So I log back in at about 7:45. We'll start coming back in for class at 8. Zoom. Okay. All right. So that was missing from the recording, but we took the symbolic or the algebraic expression, made it a numeric expression, and then we use order of operation to do the arithmetic and brought it down to 9 plus 20, which is 29. Okay. Next problem is this bit. 61 got it right. Oh, that looks nice. So still we have like 40 or 39 percent, but for the most part, I think you guys knew to set it up. This is the from coming from that, so 5x goes first, 5x plus 4, and we're going to subtract. And I told you be mindful of the fact that we subtracting the whole expression. We're not just subtracting 2x. We're not just subtracting 2x minus 3. We actually, it's one expression. It's one expression because you just wind up subtracting 2x and then still leave the minus 3. But when we do it as that such, we say the first thing to do is to get rid of parentheses. Even though we put the parentheses there, we put them there to hold the space and it helps you when you doing expressions because sometimes you got huge expression and I just want to make sure I keep the order. Because this sign, this negative would tell me make the opposite of every sign inside. If I did not put this parentheses, I probably would only made 2x negative and forget about 3 in the back, which happened to most people. So again, 1, I'm going to have 5x because there's nothing out here. It's 1 and it's a positive 1. It's nice. 4 comes back also. 1 times 4 is 4. Now we're going to do a negative. Negative times 2x, negative 2x. Negative times 3 is a positive 3. Again, if you didn't put the parentheses, you would forget to distribute and realize that this also gets the negative. Again, in front of the parentheses, it's to give me the opposite sign of everything inside. 2x is positive, so now it's negative. 3 was negative, and now it's positive. I want the opposite of the signs in there. That's what that's saying. And from here, we subtract and we get, we group like term minus 5. 5x minus 2x is 3x. And 4 plus 3 is 7. That's where the answer came from. 3x plus 7. I can look through to see if anyone had 3x plus 7. Like this is a 3x plus 7. I'm gonna make it correct. They just space it crazy, but it's okay. And I think that's it. The one with 3x plus 1, you got caught with not putting the parentheses. If you don't put the parentheses, it's going to look like that. And they're going to say 4 minus 3. 4 minus 3 is a plus 1, but it's not correct. You need the parentheses to say we distribute and it becomes a positive. Okay. So be mindful of that. It's a common trick. We don't have much. When it comes to parentheses, they don't have much. They put a negative in front of it because that's really the only thing you really must remember. The chapters on the midterm will be 1 to 3. It's going to be chapter 1 and some of chapter 2 and some of chapter 3. That's what's on the midterm. And the questions I've asked is all what's on the midterm. I haven't asked any question that I didn't see. I didn't ask some geometry question for the other class earlier. Hopefully I get to it with you guys, but I didn't see those questions on the midterm. So it can get real difficult and crazy. So I'm just trying to stick to the questions I kind of see. All right. Let's move on to the next one. All right, so we got that, and I need to update. Okay. Next is this answer was 15. So here's a question you had to solve. That's the one I told you was similar to the one online. And 72% got it right. That's nice. And this one also got it right. They just put x equal to 16, 15 I meant, so I'm gonna make that correct. Just she put if the computer is just not smart enough, it can't read that. I teach computer science, and part of it was telling the student
I think that was me.
it needs direct language. You know, you have to tell it the truth because if you say something that is not useful, it's not going to operate. Computers don't know how to think. Like I could tell you something backwards and you still get it. Do that to the computer, it's going to give you an error, a crash. All right, I'll go over this one. I'm not sure. Someone messed up the sign. Let's go over real quick. And these type of questions, you have to be careful. So 10 minus x equal to minus 5. It might almost look like it's a one-step problem, but it's not. It's actually 2 steps. So first, I'm going to get rid of the number next to the x, so it's a 10. We're going to minus 10 on both sides, minus 10 and minus 5. That looks nice. So we have, I'm going to put a 0, but I'm not going to put the 0. It's just 0 minus x, but I'm not putting the 0 space. Minus 15. Right here. This is not done. This is telling me negative x is 15. It's not telling me x. It's telling me negative x is 15. From here, though, you should see that this is true. Because if this is negative and this is negative, then if I get rid of the negative, x is positive, right? So that is true. If you want the actual mathematics to it, they sometimes divide or multiply it by a -1. They multiply, divide by a -1. But I'm telling you, you should be able to spot that by looking at it. Here's another thing you should spot. If I say negative x equals to 4, you should know that x equals to -4. There's no action should be needed because think about substitution. The only way this is going to be positive, it must be a negative number in here, inside of the x. The only way I'm gonna get positive 4 is if inside of this x is negative 4. And the negative times the negative. That's the only way that's going to be positive. So you have to start thinking in that manner sometimes, and it'll help you in solving these equations. All right, so that's 15. And I think a couple people got it. Let's go to, did I do change? Yeah, I did change some stuff. Update. So next is this problem I told about distribute. Oh, nice. 83%. Most people got it right. 23 on 2 minus 7. This one is also correct. I'm gonna give this person just the spacing. So that's good in terms of syntax. And
So
also,
what's the answer? The 2x minus 27?
excuse me. Yes.
Yeah, because that's the one I got wrong.
No, it's right. It's right. 83 got it right. I'm wrong. My fault. I'm gonna click adjusting and I'm getting rid of this answer altogether. That's the wrong answer. I don't know how I put 6 there, like I was asleep. So that is the correct answer.
I think you don't be having your glasses on, Ferg.
Yeah, sometimes I do. I didn't have it on, but I projected on the big screen, so I thought I was seeing everything. But yeah, I don't like my glasses. I don't. Try to avoid them as much as possible. All right. Update. All right. So the two, let me actually, most of you got it right. So I'm not sure if I should even go over it. One person made a mistake in terms of putting the 3, and I think it's just the order of operation is the negative that didn't get distributed. Do you need to see this one? Yes, no. That's a question to you guys.
So now,
All right. We'll keep it pushing. Next is solve the equation. So this one, these are all correct answers. The only reason I kind of, my answer was set up to, so the computer, I don't know if I should even waste time on this. I'm giving everybody the credit for this. So even if you got it wrong, this is one of those questions I'm giving. The correct answer is 5. It's not 5. I think it was 6, 6b plus 5 all over 2. This version, so if you put this in a computer, many times it doesn't read. That's why I put my parentheses around it. It's the same thing. This is just to make sure you keep the top together, because some people put it like they'll do 6b. When you put it in a computer, you could do something like this, and it'll do this, and that would not
here.
be, this would not be the same answer. So that's why I put it around parentheses, but I know you guys know what you're talking about. This is also correct because when they have common denominator, we put it under 1. So it could be written in both ways, but I would give all you guys credit because I think you know what's going on. When, as long as you got 6b plus 5. Okay, this one is correct. This one is 3b because they broke down 6 over 2. This is a nice one. This is definitely right. Right, that's a good breakdown of it. 3b and 5. A lot of you guys did well over here. Wow, you guys did well. But unfortunately, you're gonna get the credit. So people who didn't get it right will still get the credit. You guys all look like you got it. Wow, I'm proud of myself. I'm sorry, I'm proud of you guys. Sorry, like yeah, just about. Just a couple people messed up with the sign, but you got to be mindful when we move things over, the sign change. So even though we have the negative signs, when we move it over, they become positive.
Even that 5 plus 6b over 2 is correct, right?
5 plus 6b over 2.
No, at the top, the one all the way at the top.
The first one.
Yep.
I would say yes, but all right, I'm gonna show you what it looked like. If so, I think the person who write it down have the right idea, but the computer would read this in this manner. It wouldn't read it correct. The computer would read it like this.
Like it was a division problem.
Yes, and it only will divide the last number. Remember, order of operation? It's going to go from left to right. So it's going to say 5 plus 6b and then divide by 2. That's what the computer going to do. Computer going to say 5 plus 6b and divide by 2. But you don't want it to do that. You want it to say 5 plus 6b, then divide by 2. But whatever, I would give that correct. I'm just saying make sure you understand that syntax. It's different. But all this is correct. So I'll just kind of waste your time. Not waste your time, but what I'm gonna do, I'm gonna adjust this to say give full credit to all exam takers. Do I have to do something else? I think that's it. And update.
Give me 100. Next one.
Let's all right.
Oh, I wasn't.
Oh, that's the only one you got wrong? Okay, you're all excited. All right, here we go. The perimeter question. This is actually, as I say, something we're gonna go over later, which like more like geometry question, but it is a substitution question. It's the width measuring 7 and the length measuring 14, and we thinking about the rectangle. So we have 7 and 14. And we need to know what's the length around all of it. This is also 14 because a parallelogram has 2 parallel sides that's equal. All right, so it's like that. So it's 14, 14, and another 14. 3 times 14 is 42. And you could plug them in the formula. 2 times the length, as you see, 2 14s, plus the width, 2 times 7, 14. So you could visualize it and see. That's why the answer is 42. And 77% got it. So that's good. It's no adjustments. Next is another 3 steps. Not 3-step, 2-step problem. We solving it and I want to know what X is. 94% got it. Excellent.
Yep, that was another one for me that it marked it wrong.
I did?
Yeah, I have 6 and it's saying that your answer say 12.
Yep.
Uh-huh.
Oh, the answer is 6. I'm sorry. I'm looking at the right answer. The answer is 6. You're not wrong. You're all
Yeah.
correct. I'll make that adjustment again. So 12 is wrong. Let's work it out to make sure.
Yeah, because I plugged it in and that definitely was right.
Yeah, right. You checked your answer. -60 minus 12 plus 5 is the -7. Excellent.
Mm-hmm.
Excellent. So let's go over this. I shouldn't even go over it because 94, you got it. I'm gonna stop. I'm gonna stop myself. It's like I'm only proving to myself. It's 6 is the right answer. You guys know it. Unless somebody wants to see it. So I'm gonna adjust my score. 6 is the right answer. I'm gonna get rid of 12. And I check adjust score. Update. Oh man. What just happened? What just happened? That was 12, this one. And I supposed to make that right. Hit adjust score. I'm gonna get rid of 12 altogether. And that should be the update. All right. Okay. Feel better?
Excuse me, Mr. Ferg.
Yes, good evening.
Um, did you do the slope when you had the y something equals mxb, something like that?
I didn't get there, but that also will be flagged, so don't worry.
Okay.
That's another literal equation. Again, I
Okay.
flagged both of them today, so I'm gonna do it for you guys. So you'll get full credit or whatever. All students get credit. So this one, how many people got it right? 77. This answer is also right. 16 of you said this. 16%. I'm giving that to you. You just happen to put one when I didn't put one, but it's the same, mean exactly the same thing. What's missing here? So this one is missing. You're missing something. But this expression also is not in the simplest form, right? So 3x, you would have to, at least you have to simplify 5y and 7y. And also 4, you needed the 4x. It was missing 4x. So this was missing some step, and that's why. So when we're doing this, you got to remember group and like terms. It's one of the technique you'll need going forward. Because remember, I say these problem, they all are multi-step till they get to what I've been saying is a two-step equation. But most of them is going to be multi-steps getting down there, and you have to be careful as we go through. Again, the like term is 3x, and it's because there's the letters and the power of the letter, because x squared is not an x. So those are like terms. But even if you do this, that's not the simplified version. Once we do this, we got to say, oh, that's simplified to -1 or 1x, whichever you feel like saying. You know, negative x, that becomes, the other side is -5y minus plus 7y. -5 plus 7. You can put that in the calculator, worst case. -5 plus 7. This is 5 minus 7. That's plus 2. It's a plus 2. And then order doesn't matter. So even if you had put 2y minus x, it's still correct. Order doesn't matter when it comes to addition. That's what that is. So I'm going to update for the second one to get it. And okay, keep pushing. So this is the one I was talking about. Correct answer is B minus, yep, you guys got it correct. On top is right. Y minus BX, is it the same? Yep, this is also right. You just put it around the wrong way. I'm just clicking on the ones who got it right. You guys did good. Literal equation. So all this stuff that I will flag will come up next week. So those are all right. This also is correct. They put the minus B in front, minus MX. That's correct. This one you solve for the wrong thing. You're supposed to solve for B. You solve for M. You solve for X. You're supposed to solve for B. And this one also, I think this is not supposed to be a slash. It's supposed to be an equality. So B would equal that, not divide by it. But anyway, those two that's off, that's not terrible. And it should not be a number unless you have numbers given. Remember, only numbers we could simplify. So if numbers not there that we cancel out and multiply out and times it to get a number, we can't just put one solid number from these algebra. You cannot just have one number unless you had a series of numbers. All right, so this one again, this is you're getting all the scores. So I went over it because it's coming next week. Right? It's just that student would say it wasn't fair. So I didn't think it was difficult, being that if I had to do this, I'm solving for B, meaning I want to get rid of anything that's not B. It's really a one step. I'm getting rid of MX on both sides, y minus mx. When I draw that line, I'm left with b plus 0, and b plus 0 is equal to, on this side, the right side is y on top, and y will be minus the mx. That's it. The answer is there. Even though it looks like that, this is the same. Equality says A equals a B if and only if, or then B equals to A, whatever. They must be true. So I can do that. I can rewrite this. B is equal to Y minus MXY minus MX. That's a bit weird. Sorry. Terrible. I'm having a hard time with my pen. I don't have my tablet is broken and I didn't get it replaced, and my mouse is difficult to write with. In fact, I can't find the tablet. Let me say that. I don't know where it's at, so I can't even fix it. All right. Clear the drawing, and I gave credit to everyone. So all exam takers will get full credit. All right. Next is next. That's it. Next is to simplify this. Again, it says simplify because I'm not going to say distribute. I could say distribute, but sometimes it's going to be more than distribute. So I have to say simplify, because when it's going to be a series of different multiple parts, things happening, I can't just say distribute, because again, the student was saying, why you didn't just say what it is? Simplify meaning you might have to distribute, you might have to combine, like turn, you might have to do a series of stuff. So I'm going to just say simplify. All right, so I'm going to look at, this is -2 times 3x squared. The answer is negative. That first term becomes -6x squared. That's just the first term. Now I must do the same thing again. -2 get multiplied by the negative x. That become a positive x. Exactly. Students tend to forget. They always remember the first term. And they tend to forget the other terms in the set. But all the terms in the parentheses must get -2 times a positive
It's
7.
X.
Say that again.
It should
It's
be
positive
2x.
2x.
Okay. Thank you.
Mm-hmm.
It is positive 2x. And that's why you guys are acing.
This was a problem that I was talking about with not being able to put that exponent. I just put that shift 6.
I got you. So you got it wrong. That's okay with you.
I have a question about this one as well.
This is the second one is yours.
I guess so, yeah. I got everything right, but that I'm not used to that.
And I put 2. That one right under. I put 2.
Space. It's okay. It's okay. All these are good to go.
Professor, I have a question.
This one is missing the X, but I think I understand. I don't. Yes, what's your question?
So I simplified further because they were all divisible by 2, and it said that that was wrong. Are you not supposed to simplify past that
Yeah,
answer?
yeah, you cannot. The
Okay,
only way
gotcha.
you'll have to do it, if it was set equal to 0, in part of solving it, I would divide it by 2 to work with smaller numbers, because 0, if I divide both sides by 0, it don't change the 0 on the other side, and I got the number smaller. But in this case, you can't just divide it by 2. Like, you just pull the 2 out the space. You just multiply it by 1/2, and that wasn't asked. You get what I'm saying? You multiply by 1/2 when it didn't. So these last ones, I don't know, a couple of them are off in terms of the signs, whether it's not -6 or one of them is just missing. This is just missing the X altogether. But it has to be an X squared, so I think that's just formatting. This one missing the negative, so I can't. This is negative, but is this right? This looked like the right thing also. Right? So why is it? Anyway, I think it's right. And this one is, it's already checked right. This one is wrong. They did it like how I did it. They didn't put the 2. And this one, the signs are off. So those are the ones I would give credit to. You good with that?
Just don't forget my credit, that second one.
And
Oh,
don't forget mine either.
everything with red got credited. Um,
I don't think you checked mine.
which one is yours?
The one with the 2, when I put -6x2, because I didn't know how to make an
Which one?
exponent. Up 1, up 1. No, it's right there. -6x2, right there. Yeah,
It is checked.
it is. Oh, couldn't
Yeah.
see it. Thank you.
My issue kind of lie with these 2 right here. You're missing the X. You see it? Because this is not right. This is just going to say -36. Since someone had -36 earlier, so I can't even. I apologize for these 2 students here. I think you might have the right idea. Well, this one. But it didn't come out right. There's no X. You're missing the X altogether. X square. See, if you miss the little hamper or something like that, then I can see you don't know what you're doing. Just don't.
The one above it has the X.
Right, but this, I can't
Oh.
make this one correct. You see what I'm saying?
Yeah.
Because this is saying -36 by itself. There's no.
Yeah.
All right, sorry about that.
Got my honey.
All right, and I think that's all. That is all. I think the updates, I'm not sure. I think you could run an update like I don't know how you guys do it, but if you run your review, you should be able to see the update as soon as I saved just now.
Be right back.
Maybe it needs to adjust. I don't know. Hopefully, because it's still a server, right? It has to update itself. But I think when I change it, maybe it changed, and then when you run yours, it should come back. Students come in and out, but I think we're close to the 17 student that took the exam. All right, so now I'm ready for today's lesson. If you guys have any questions, you can feel free to ask it now. If not, to today's lesson. Clearing the fraction. What am I doing here? All right, slideshow real quick. 2 steps, that's where we stopped last time. And this part I didn't get into too much. It's coming for the next class, so we're supposed to complete it last week. I did it, but I didn't test you on it. I did go over it, I didn't test you on it. They say the best way to cancel it out is the reciprocal. The visuals let you see it. The easiest way to operate in terms of this is to say, look, 3 cancels out 3, and 4 cancels out 4. They'll always do it. Whenever I have a fraction, I'm gonna always multiply by the flip because the flips will cancel out the numbers. It's a quick way to get 1, and 1 times x is x. Right, look on the left side. 1 times x is x. So that's how it goes. So I start with some type of fraction on the x. I'm gonna multiply by the flip so I can cancel it out to a 1, and then 1x is x. 1x is x. That's it. And it just depends what's on the other side. So this happened to just be the flip, 4/3, because this is a 1. If this was a 10, it would have been 40/3. You get what I'm saying? And if it was like 6, it would have been 24/3, which is 8. Whatever. Okay? Hope I didn't confuse you. All right. Why did I go over this? So going through, I just want to go over some of the key concepts. what you should take away from this or the last session. Everything we call is called linear. Once you see x to the first power, it's a straight line. It represents straight line. You don't really know what it means now, but that's why they call them linear equation. Whenever I plot this, it's always plot a straight line. It's a bunch of different curves in the world or function when you work with, but this is the only one when x to the first power. Anytime you see x to only the first power, it's a straight line. Once you see anything other than that, whether it's x squared or root x, all these are curves. All these are curved graph. Only x to the first power is a straight line. That's why they call them linear. And they teach you linear equation because linear equation can break down any curved graph. All I need to do is do a bunch of straight lines and I can get the curve. If I have a bunch of straight lines, I can recreate the curve. So we always teach linear. Everything gets approximated to the linear anyway. Solving linear equation, they tell you what to do. Find a numerical value, replace it to see if it's true statement. That's actually the plugging in. Once you get it, you test the answer. You could check your answers. Always check your answers. They tell you the first thing to do is isolate your variable by adding to the opposite. So you're gonna add or subtract first, and then you're gonna isolate the next variable by dividing or subtract most of the time. Divide or multiply meant, not subtract. So first you add or subtract. Second step is divide or multiply. Depends on the setup. And usually it's a division if it's a 2x. All right. What else I had to say about this? General equation, condition, like terms. We looked at the like terms. Something we're going to do today, conditional statement. You got to understand, not every equation can be solved. Some of them don't have a solution. What it means, remember I told you, these represent straight lines. So some equation will always be true. If I give you two lines, like I say, I give you these two lines. Line X is line X. So this is actually the two line. This is the same line. Line 1 is line 2. So every number, when X is 2, the other side is 2. When X is 3, the other side is 3. So they call this is infinite solution. In the conditional equation, they consider this to be true. How do I know it's true? If I do the algebra and I solve for X, let's take away X from both sides. These answers wind up to be 0 equal to 0. If I take away X from both sides, I'm going to get 0 equal to 0. This is important. Remember, we solving a bunch of equations. I'm telling you, some equation going to have infinite solution. Every number is the answer. Every real number is an answer right here. So they call this infinite solution or many solution, infinitely many solution. This equation could never have the same solution, never. If I pick X to be 0, this tells me 1 equals to 0, which is a contradiction. 1 cannot equal to 0. This can never have a solution. This is no solution. These type of problem has no solution. How would we know? Because there's no value of X will make the statement true. No solution. Again, no value of X will make this true. And these are really the elementary state. It's going to be multiple steps. So it's going to look at huge. They're going to look crazy. They're going to look like a larger scale of problem, which you have to reduce it to get to this stage. So you're going to have to do multiple steps, and then you're going to get to you're like, oh, they're the same thing. There are infinitely many solutions. Infinitely many solutions. Infinite. Infinitely many solutions. That's what you say for that. So when you do the algebra for the infinitely many solution, they always cancel out. And if you really observe it, you see that both sides of the equal sign are equal. Both sides of the equations are equal. It might look something like X plus 2 over here going to be x plus 2. Whatever it is, they will be the same on both sides. That's how we know it's infinitely many solution is one line. This, they never touch. This is like this. This is x plus 1. There's no number that's going to put me at the same point. There's no number. So these are a special case. The one we're used to, the one we've been doing, will be the one where we have one solution. The one you've been doing is, this is what we've been doing. Whenever we solve these two lines, we've been doing the one that has one unique solution. They have one number that satisfies both conditions. There's one number that satisfies one line and the other line. That's the one we've been doing. But they're introducing this at a higher level to let you know. I can give you an equation that one you cannot solve because there's no solution, or it's every number is a solution, but you should know how to differentiate both. So I don't know if I'm gonna ask those type of questions. I tend to just ask the one where we just straight doing algebra and solving for the one. But this is something to know. So I'm letting you know. Right. I doubt I'm gonna ask you that question. This to me is like more of a theoretic math question. Like if you're doing problem in real life, you're not gonna do something that don't have a solution. But sometimes you might be modeling your problem and realize, oh, I'm looking for an answer when there's no answer to it. So it might be necessary. I don't know. I can't imagine. I don't have any nursing example where you're gonna use no solution. All right. What else I gotta say? I think that's all I have to say. That's part of today. Clearing the fraction is something we're gonna do also. Look at this. When we clear the fraction, we multiply by 10. The main reason we multiply by 10, we actually clearing the fraction here in the decimal. People like whole numbers, you don't want to work with in the decimal. But just remember, do you know that 20, this is the same as saying 23 over 10. That's why we're going to multiply by 10. The decimal, one decimal place is to the 10th. One decimal place is to the 10th. So to get rid of the decimal, they divide everything. I don't really know how to show, but say 2.3 x is the same as saying 23 x over 10. Remember, these decimals are like fraction to the 10th, meaning these are all over 10. To the 10th, meaning these are all over 10, and that's why they use this 10 to multiply. So a decimal is really a fraction. A decimal is a fraction, is multiples of the tens, right? So that's why this a 10 comes out here. If it was two decimal places, we'll multiply by 100 to clear the decimal. We do that a lot with money. Problem with monies, like 25 cents or 15 cents, we're going to multiply that by 100, like the 100 cents, right, to clear the decimal, almost like the percent. Look in this case. To clear this, we'll use the LCD. If it was all 5, if everything was 5 equal denominator, I'll multiply by 5. But because we have two different denominator, I need the LCD. I need the LCD to multiply. Look at this. When I multiply with the LCD, look how it becomes nice. I took this fraction and I multiply it by the LCD. 15 times, well, this side first. 15 times 1/3 is 15 over 3. 15 over 3 is 5. 15 times 1/5 is 15 over 5. 15 over 5 is 3. 15 times 1/5 again is 15 over 5, and 15 over 5 it's 3. Same thing here. 15 times -1 is -15. They call that clearing the fraction or the decimal. We like whole numbers, and that's what I would tell you. So that's the only thing. I didn't go into any fraction operation to solve the problem this week. because I say I'm going to leave it to this next week. Because you can, your common sense will probably say, get the common denominator, add up these functions, do a bunch of stuff. But I'm saying, no, just multiply by the LCD, and this nice fraction, this ugly fraction become this nice whole number. Same thing here. This ugly fraction, decimal become nice whole number. Also, I want you to notice something. This is the simplest stage before you start moving the variables to one side. This is the simplest stage. Many of those multiple steps, you will come here before you stop. When you come here, it's hard to simplify anymore because you have all the x's and all the constants on one side. You got all the x's in one place and all the numbers in one place. This is the simplest you can do. Now to solve, you move things around. I'm gonna put all my x's on the left and put all my numbers on the right. But you always have to get here first. When you get here is where I could tell if it's going to be no solution. Because if I get here, guess what? If I see this, both sides look the same, it's infinite solution. It's the same line. If I look at this and they're the same thing, it's infinite solution. And you can try to solve it. When you solve it, it's going to be 0, 0. It's going to cancel out each other. Once you got 0, 0, then any number is a solution. If I simplify this and I get 0 equal another number, it's no solution because that's not true. It's a contradiction. 0 is not another number. 0 is 0. So because of that contradiction, we'll say it's no solution for that problem. But again, we're clearing the fraction, and we clear the fraction just to bring it right here to where we can actually solve this problem. Should I solve that problem? I'm gonna solve that just to say the steps to solving this. I like to say move the letters to the left. You can move it wherever, but I like to put my variables on the left. So I would get rid of the variables on the right. I'm getting rid of 12x on the right because I want all my x's on the left. So wherever I see 12x, any x's on the right is going to be 0. Any x I see on the right, I'm going to be 0. So I got to add 12 to both sides. 12x. Sorry, it's just difficult to navigate this mouse and that little space. Two x. So that's 2x. And in the same manner, I can get rid of 28. I can minus 28. I'm being lazy. I'm doing 2-step in 1. And I can minus 28 here. I'm not sure if that's clear. Might not be clear. Might not be a good place to do this. I'm gonna write the finished product, but don't worry, I can always repeat that. I will add it up and I see 23 plus 12. 23 plus 12 look like 35. 23 plus 12. The left side becomes 35. X plus 0. The left side becomes 35x. The x is moved to the left and the numbers are gone. The number is 0. 28 minus 28 is 0. And that's equal to, on the left side, on the right side, 12x minus plus 12x is 0. The x's are gone. I have 98 minus 28. 98 minus 28 look like it's 70. 98 minus 28 is 70. I'm working on this bit right here. I just did this. So the left side reduced 35 plus 23 plus 12, and 28 minus 28 is 0. And the right side becomes 70. And look, I did it in one shot. Usually we move the x first, and then the next line I'm gonna write it over and move the numbers. I can move it in one shot. And that's why I say this is where we want to bring all our equation, because once you bring it here, you're ready to any multi-step, you're going to bring it to a place that's this, and then you're going to move all your x's to one side, move all your numbers to one side, and then we're going to solve for 1x. I don't want 35 of them. I just want 1x. So don't give me 35 x's. So let's divide away 35. And 35 into 70 gives you 2. So the solution for this x equals to 2. Remember, I tell you, not all of them have solution. This one does because they're different. Different coefficient of x. In fact, once the coefficient of x is different, you will get a one solution. For me to get infinite solution, or look, they have to be in the same way. For this line to be on top of each other, they have to have the same x value. For this line to run like this, they must have the same x value. The constant will be different. No solution, all solution. I'm not sure if the visual is good. I kind of remember things through pictures. I'm not sure if that's useful for you, but whatever. So we'll get to other problem, but I just wanted to show you quickly what we'll do. Again, even though this is fraction, we get here, and guess what we're going to do? Move all the x's to one side and move all the numbers to the other side. -3, -3. That's positive 2x equals to, on the other side, -18. And I could tell you -9 will be the answer. 2 times -9 is -18. Or I just divide both sides by 2. I divide both sides by 2 and my answer is -9 for the bottom one. So what I did, I continued the step to show you where to go. It's multiple step, but once we get here, you're pretty much almost done. There's really 2 steps left. It's to move the variables to one side, and in the same hand, I'm moving the numbers to the other side. I like my variables on the left. It may work out that the variable is on the right, whatever is easiest, whatever is best for you. I just teach it in one kind of technique because this is the way a computer programs it also. You got to define the x and put the input in. You don't see it like -9 equal to x. But I can do that because we're not computers, so I can look at it and know it's still the correct answer. The computer wouldn't. Any question with clearing the fraction? No, it's a lot, but clearing the fraction again, we multiply out to get whole numbers. We multiply out to turn this ugly rational, it's not really rational, but this fractional equation to a nice integer equation. So that is this is the thing I was called. They call them literal equation, symbolic equation, analytic equation. You got these different ways of saying it. It's just saying I'm leaving the variable in there. Example dr. I can solve this for different one. I can solve this for t. This is distance formula. Distance is the rate, is the speed time time. Speed time time to tell you how far you travel. If I know how fast I'm going, you're going 60 miles an hour, and you've been driving for 2 hours, I know you drove 120 miles. That's how I know the distance. You're going 20 miles an hour, and you've been going for 5 hours, I know it's, what's that? 20 times 5 is 100 miles you just traveled. And they say we could solve, what if I just want to find time? They say just divide away the R. So this system is done the same as I say, I put it on your exam. So you saw it just now, even though I gave credit for it. And many of you already know what to do. If I'm looking for this, I'm isolating the variable. I'm looking for t, I'm going to divide both sides by r. That's it. That's why t equal to d over r. See, likewise, if I'm looking for what? If I'm looking for r, I'm going to divide both sides by t because I want to get r by himself. It's that easy. So r is equal to d over t. That's how they get this from the simple equation. That's called a literal equation. Literal because we're not putting numbers in. You're used to having numbers, you know, and we're not putting in numbers. So we just leave it that. Later on, we could put the number. What's the distance traveled? How long? And I can tell you how fast the vehicle was going. You know, how far did you go? How fast did you drive? Okay, took you like 2 hours, right? Given some time. Here's another example. Again, you guys kind of did this right, so I don't really want to spend too much time. But it's done the same way with the numbers. The difference is we're not simplifying. This one, so look at this case. So they say solve for A. This is A. I got to isolate A. That means I want to remove B. I want to isolate A. I want to remove B. How do I remove B? Take it away. Literally take it away, make it a 0. But what I do on this side, I must do on the other side. So since I take away B over here, I will take away B on this side also. See P, and I'm taking away this B. I'm going to take it away here also. So this new side says 2A is equal to P minus B. This B is gone. This is an equivalent equation. And now I want just 1A because I don't want 2A. So I must divide that by 2. I must divide that by 2. 2 cancel 2. And that's how I get A. So that's a literal equation. That you saw that on your quiz. And I said a lot of you got it right. Over 70-something% got it right each time. So I'm proud of that. Even though I gave you credit, because as I said, it's showing up now. It's the second part of our lesson. It wasn't in the first part that I quizzed you on. All right. Key takeaway from chapter is general linear equation. I told you coefficient is 1. On one side of the equal sign, simplify both sides of the equation, combine like term on all the same sides. So you always work on one side, simplify each side of the equation. Remember, I told you, bring it down to where you have a letter and a number, a variable and a number. That's the simplest. You're going to stay on one side till you get it to the simplest form. That'll help you to avoid mistakes. And once you get it to the simplest form, then you move the x's to the left and the numbers to the right. Always reduce each side of the equation. What did I just do? Most linear equation that you will encounter are conditional and have no solution and have one solution. Yes. I don't know if I'm gonna ask you those one with the infinite many solution and the no solution. It depends how much I can. I doubt I usually don't ask many of those. Maybe I could ask 2. It'll be a word problem. Well, your answer being words. So you might think you're gonna enter a number, but you'll have to say no solution. I don't know if I'm gonna do that. Usually we have to solve something because if no solution tend to be less algebra. And because I want you to solve something, I doubt I'm gonna put those on. But I'll let you know before the week is done. I have to send Miss Loach some information because some things on this topic I don't know how to test. So she's gonna show me if I could try and put it into the system. We'll figure out how to do it. So here we go again. When we solve in the conditional statement, as I say, most of them gonna give you a number x equals to, and we have the number x equal to 5, x equal to 6, x equal to a half, whatever, x equal to a number. That's the ones you're gonna see the most. However, they have the case when you do the algebra, x disappear, everything disappear. They disappear, but both because both lines equal each other. This is infinitely many solution. Then the answer identify and the solution set consists of all real numbers. All real numbers. Any number you put in there makes it true. Remember I told you like x equal to x. The left side must equal the right. They're the same thing. The left side must equal the right if they're the same thing. And then when it's all false statement, it's a contradiction. There's no solution for this problem. X plus 1 could never equal to x. X plus 1 could never be x because that one is always 1 greater. That's what they were showing. So in that case, they say it's no solution or the set is empty. I don't know if I use that symbol as empty set, but it's false. There's no x that's going to make it true. That's why they say it's empty. They say put all the X in this bucket, that's gonna make that statement true, and nothing gonna make it true. Right? No X. If I have a formula, an equation, X equal to X plus 1. Remember, these numbers will always be equal. So if X equal to X, this plus 1 will always have this one higher. It will always be 0 to 1. And it's not true. That's not a true statement. All right. That's contradiction stuff. Oh, should do this. So some sentence, some words they talk about when it comes to geometry, they're gonna have different problems. Solving percent. Geometry is like the shapes, and geometry you must know about squares, rectangle, circles, triangles. Triangles, rectangles, square is a rectangle, and circles are the key geometrical shape that you should know the perimeter and how to find the area. You should know the perimeter and the area. A lot of algebra question will assume you know these things, and you'll have to manipulate the algebra based on given the perimeter, you got to find the area, or given the area, you got to find the perimeter. So I'll do that. Like I'm just talking now, but hopefully I get a question that I'll go over. In addition, these are some words you need to know, because you'll need to know that for breaking down some word problem. When they say sum increase by more than plus added to total, that's all a plus. This is all addition. So if I use this in the word, sum two numbers, we add in those two numbers. A number was increased by another number, we add in that number. One number was such more than another number, we add in them. Difference, that word, make sure you know that word. A lot of people they still see difference and they add. I'm like, I can't help you. Decrease by, subtract from, less, minus, all that means to take away. Decrease. The difference is. The difference we're going to take away to know what's the difference. Product, the word product means to multiply. Or the word of times twice of something. I don't know, twice. I guess twice means multiply. Yeah, like 3 times. Yeah, if I say twice. I don't like, so twice means multiplying by 2, I guess, times 2. So yes, I could say twice and you got to know it's a multiplication, I guess. Like if I say half something and you're multiplying by 0.5 or 1/2. So similar. So some language matters. I can't list all the words. It's really how it's used in context, and you have to really be careful. I got to be careful many times when I read. I only get math problems wrong, well, when I speed through and not pay attention, or I just misunderstood the question. I don't know what they're asking. So, I assume when I do something totally different. So just make sure you understand the question so you don't make a mistake. What's the worst? I know students who are like, oh man, I know how to do that, but you didn't understand what they were asking, so you didn't do it. All right, quotient means to divide. So divide by ratio per all these division problem. 1, 2, and sometimes into 5 into this or that, like, 1 is done in like how much work is done in such time. It all depends. Those are all ratio problem and they break down in a fraction. Is total results equal? They all equal. They all equal. This also tend to sometimes be vague, so it depends on how the language is used. Not vague, it's clear, but they might not they use is a lot. Or maybe they say everything add up to. It just, you have to pay attention to the language again. But again, these are just some key words that shows up pretty frequent, and this is what it means. Quotient is to divide, product is to multiply, difference is to take away, sum is to add. In addition to all these other numbers. You must know those. It's going to come with some word problem later. Backward substitution. When we find an answer, I don't know, we're going to undo. So I guess they say backward because we're going to get rid of the parentheses. They group in like terms. So the step is to get rid of parentheses first. So get rid of parentheses, group the like term. Once I get rid of parentheses, I got x plus 3x. It's 4x. Usually this is what you have to be mindful. When it's in a plus, it's good. I'm usually not going to give you a plus. I'm going to give you a minus. Because a minus means you got to change something inside. I want to see, are you paying attention? Or do you know exactly what to do? Because sometimes you do things on autopilot because you don't know you're supposed to change the sign. If I force you to change the sign, then I know you know what you're doing. All right. In that case, we're gonna move two to one side and see. It's just a simple two-step. Once you group the like term, that it becomes a simple two steps from here. We're gonna add and then divide, and then they say check your answer. 5 get plugged in, and we see what it worked out to be. I talked a little bit about the rectangle. Perimeter is the length around the outside of the polygon, they call this. Polygon is a closed-sided figure. So polygon has 3 sides, a triangle. Polygon got 4 sides, like rectangle. Polygon got 5 sides, like a pentagon. 6 sides, like the hexagon, and so on and so on. Some things to know. Square got all equal sides. So for a rectangle, because the length and the width are the same, it's just saying 2W plus 2W is 4W, or 2L plus 2L is 4L. They just call it the sides. So 4 sides, because they're all equal sides. Circumference is what I tell you must know about the area of a circle. The perimeter of a circle. Okay, so they strictly was focused on perimeter and not area. I noticed that. So I didn't see any area problem. Maybe it's coming later. But again, a circumference, the perimeter, oh, they call it the perimeter. All right. Sorry. That's the formula they gave. The perimeter of the circle is called the circumference of the circle. Protect the perimeter. Protecting the boundary, the border. We did this already when we did percent. I'm not going to waste time with taxes. But this is how we solve the backwards one. I told you just insert this into your calculator. We use the cross product for this one. We use the cross product. And the only way you could have done this problem was to reverse engineer. Well, you guys found out that we multiply when we got to take the tax, so we divide in this case. But this is the best setup. I want to know, so they gave me the part and they gave me the percent. If a pair of shoes cost that, including tax, what's the original? They gave me the part and they gave me the percent, but they didn't give me the original. So this percent of the part is not helping me find the whole. You get what I'm saying? So they have a trick. They say, you know what? We're going to set it up in an algebra question. If the original shoes cost this, and it includes the tax, then the original price must be, they put it like this. Here's the original price plus a percentage of the original price, which is the tax. This is the shoe plus the tax. They simply factor it out. This is one time that. And again, it's a division problem, like I said. They divide by 1.05. To find C, you divide away this number. We done this problem already. You can do it with the cross product. They've shown you now how to do algebra. I use the cross product because I didn't give you algebra before. Now you have algebra, you'll be able to set it up in terms of, hopefully we'll go to a question similar. Rate and speed, again, with some word problem, they want you to know, they give you that formula, distance is rate times time. They expect you to know it, similar to the other ones. For now, you're gonna get it, you're gonna keep getting it, but it's gonna be repeating itself. By the time you finish the course in the next 6 weeks, you should know this, right? Or at least until the class ends, you'll know it. When the class ends, I don't think you're doing any other math after this. So until then, you guys got to say, you know what, I'm gonna study like I'm gonna be an engineer. That's what I'm telling you. You got to put a lot of time in, unfortunately, because you're doing a lot of work in this course. We're covering a lot of material in 1 week. Remember that. So
Yeah, but we're not going to be engineers. We're going to be nurses.
you don't be feeling just saying you have to practice. That's all I'm saying. Okay, that's all to pass the class. You have to be good students. Like an engineer student got to go hard at mathematics. But if you don't want to do it, you don't have to. But you're gonna get the results you put in. Simplify the process of solving real world problem by creating math models. I'm not gonna give you too many modeling problems. So it's something good to know, but it's more practice. If I do any modeling problem, it'll probably be something with some nursing question that you guys can envision. So don't worry too much about those modeling. The only other modeling is some geometric question. I didn't get to them with the students earlier, so I doubt I'm gonna do it with you guys. It won't be on the exam. I know that. I didn't get a chance. Understand the difference between a ratio and proportion. You guys, we did all of that already. We did all of that first times out. The cross product. So this is part I didn't include. You already know how to do this. We did that on the first exam. We had a question that requires us to set up this cross product. But now you have it officially. Now it's in algebra. Now it's a one-step equation. Before it was just a word problem that you modeled into this. Now you actually have the equation. And it's a one-step equation where, well, maybe 2 steps. At first, do the cross product and then divide away. Multiply both numbers and then divide. And that's always. This is this is the same exact thing, modeling in the ratio, they talk about it. Same exact thing. These problems are being asked in different way. I don't know if I'm gonna do this one. I will mention this, but this is a similar ratio. So whenever you see similar triangle, it's a tricky word problem put together. It's a scale problem. Similar triangle, always the same. The multiply is different. Where is it? It's a lot of kids. That's a lot of information. All right, similar triangles. This word problem we did already. We know how to model this. This is what I showed you already with the cross product. Setting up 2 different units, right? So if it claimed that 2 out of 3 dentists prefer a certain brand of toothpaste, so we got 2 out of 3 dentists, and it says 600 dentists would survey, then how many dentists prefer the brand? The 600, so what is the part and what is the whole? The part is 2, the whole is the 3. So when I look at this and they say if 600 dentists is surveyed, that's the whole section. So the whole matches up. That's why 6 goes with 3 at the bottom. The whole, the part over the whole. Let me write that. If you want to think, they use a ratio of the part over the whole. That's that fraction. And they said, 2 out of 3. So the part is 3, 2, and the whole is 3. So that's where I say you have to understand the word problem. They didn't say anything, but they say if 600 dentists were surveyed, then how many prefer that brand? Prefer the brand. So it said 2 out of 3 prefer a certain brand. The 2 out of the 3 prefer the brand. That's the part prefer the brand. So I want to know which part. That's why N is the part. The missing number is the part. We're looking for what part of 600, as a relationship to 2, to this ratio. How do I get this to be equal ratio? I could show you a different way. 3 times 200. Look at this. 3 times 200 is 6. Therefore, 2 times 200 is 4. That's what they did. They said 3 times what number? How we go from 3 to 6? How we go from 3 to 6? I multiply 3 times 200. That's what I'm thinking in my head. And if I multiply 3 times 200 to get 600 on top, I'm going to multiply 2 times 200. Boom. And that's how they get 400 dentists. They actually didn't do that. They didn't do that. They used the cross product. They cross multiply. 2 times 6, 1200. And 3 times n. That's the first step in the cross product. And then I'm going to divide by 3. I'm going to divide by 3. So if I divide away by 3, you could see that if I divide 600 by 3, it's 200. And 2 times 200 is 400. Same exact thing. Whatever approach you take. Any questions with any of these? These are the actually easy ones. So I'm going to get into what the algebra ones would look like. This is a scale question. Again, perimeter. I don't know much, as you said, geometry. I don't want to mess with it too much. Similar triangle, it's just going to be multiple. They're going to give you a small triangle and a big triangle and say, are they similar? And if this is 5 and this is 10 and this is 2, what is X? It's the same exact thing. 5 times what? Give me 10, 2. 5 times 2 is 10. 2 times 2 is 4. X equals to 4. It's the same proportional problem. Actually, I should have used the number they gave. Let me use the number they gave real quick. So I'm going to go back, take all my numbers off, and says, they tell me the triangle has a perimeter of 12 and the other with a scale factor of 1/3. Then find the perimeter of the large triangle. Right, AB is 2 different triangles being compared, and they tell you the perimeter of one and the other, and then say it's a scale factor. So it's like a 1, 2. The way we lined it up to is that, look how they said it. They said AB 2. This 2 is important, RST. So when they gave the scale factor of 1 to 3, 1 goes with the first number. 1 goes with ABC. That's why 1 lines up with 12. And 3 lines up with the bottom that we're looking for, the RS, the other triangle. So this triangle would be larger because it's 3 times 12. It's 3 times the perimeter of the smaller triangle. All right. Those are all related rates or proportion, I should say, problem. All right, interval questions. Interval question is a bit algebraic inequality. It's like an equality, but the signs are different here. It's almost like an equality, but the signs are different. They have different notation. It's inclusive, inequality, the end. We'll do a little bit about this real quick, the set theory. Trying to think. All right. I didn't get to this either with the students. So. Set theory, set notation. Property of inequality is similar to the properties of equality. If something is less than something and I add to it, I gotta add to the other side. I have 1 is less than 2. So for me to make this be true, in like this case, if I add plus 3 on this side, this becomes 4. For 4 to be less than 2, I better add plus 3 to this side also. So now 4 is less than 5, and now the inequality holds true. That's really what they're saying. Whatever you do on one side, this is all the same. Everything is the same as an equality. The only thing different, when we divide by a negative number, we must switch. What does that mean? 1 is less than 2. But if I say divide both sides by negative, if I divide both sides by negative, I'm left with -1 and -2. They say I must switch the sign because -2 is smaller than -1. See that? If you multiply or divide by a negative with the inequality, you must switch the sign. That's the only rule. That's the only rule. That's different than the equality. Everything happens like you solving an equation, inequality, unless you use negative number. Hopefully we get to practice a few of those. I just wanted to make sure I go through a few. Okay, let me just do that last one. Oh man, time is flying. Look at the clock. It's because we're having so much fun. Where is the slideshow from current slide? Set notation. I'm not sure how much we're going to work with these. I will show it to you. These are the ones I'm having issue with in terms of how I'm going to test you. Given an interval notation, x is less than 3 and x is greater or equal to 1. Okay, I might be able to ask the question as this. You got to give the interval notation. Interval notation is real quick. The hard bracket means equal to and greater than. The soft bracket is strictly less than. Less than meaning that's where it stopped. It's a boundary. The way they do these symbols, this means it stopped there, but it's not equal to. This means it stops here, but because it's a hard bracket, it's equal to. Example, if I had to put like, say, if I wanted the 3 to be a hard bracket, if I had this, x less than or equal to 3, then this side would become a hard bracket. You understand? The way they kind of do the picture, which again, I say I can't do the picture, but I can give you interval notation. This I can put on your test. Interval notation I could put on your test. Many times on the test, they have pictures that look as this one. -1, 0, 1, 2, 3, 4. So this is the number line. This means that at -1, there's a dot there at -1. In addition, the picture goes up. Everything above is a solution. Here at 3, the graph 3 is never a solution. 3 is not a solution. We get close to 3, 2.99999999999, but it's never 3. 2.99999999999, but it's never 3. That's what this says. You get close to 3, but x is less than 3. It didn't, the only way it's 3 if it has an equality there. That's the set theory. If you don't put an equal on the set, 3 is not in the set. We're close to 3, but 3 is not in there. That's why they have the soft bracket. It has to have a hard bracket for me to say 3 is in the set. -1 is in the set. -1 is in the set. As they say, because x is greater or equal to 1. That's the key. This is shorthand. It says x is strictly greater than -1. That's why we're using all the space in between. But in addition, x is also equal to -1. This is what this means. It's an OR case. It's shorthand for x is greater than 1 or x is equal to 1. This is a shorthand. And because x greater than 1, x greater than -1, I should say, x greater than -1, strictly greater than -1, looks like this. Strictly greater than -1, it's going that way. But because of this is this one. But because of this equality, we're going to shade inside of here because x is also at -1. It's a period. X is there. X is at -1, but also greater. X is not at 3, but it's less. So x is between this interval.
So these are the questions on the homework with the closed circle and the open circle.
Correct.
Yeah.
I don't know how to put them on a test, but yes, those are interval question. And it comes in for later on. It's functions and domain. Later on, this is how some questions are going to be answered. Some of those, remember those questions I say are infinite solution or many solution? You won't list the solution because it's not one number is the answer. It's a set of numbers. All these numbers make this true. So that's why they have the set like that. They have you visualize it. Any number in between here. So if I pick 2, 2 is true because 2 is in the set. If I pick 0, 0 is less than 3 and greater than -1. It's true. It's in the set. If I pick 1, 1 is less than 3 and greater. It's in the solution. If I pick a half, if I pick 0.4, if I pick -1/2, all those numbers is infinite numbers in here. So we just give you the endpoint of the set because all the numbers in there is true. Remember, we got irrational and rational numbers, got infinite fractions in there. So I can't list all those numbers. What I could list is integers, but if they don't say list the integers, I can't just say, oh, this set has -1, 0, 1, 2, 3. Well, 3 is not in there. -1, 0, 1, 2. I can't say that because I'm missing 2.9999999. That's in the set. So they write it in this fashion. So again, your answer won't just be one number anymore. It's a set of numbers. Yeah. So the boundaries was important, the end of the set, because every number is true. I want to know what's the end point. Okay, -1. And it's in the set, so we shade it in. It equals to -1. This one is not equal to 3, so it's not in the set. But the numbers get close to 3, so we bring it all the way up to 3. Yes, hopefully you could do those a little better now. But again, I don't know how I'm gonna put it. I might be able to put this part on. I might be able to do an example just like this. I can't say x is less than 3 and x is greater than something and say, give me this. I might be able to do that. So I won't ask you to draw pictures, but I might ask you to do the interval notation. Given the interval notation, give the interval notation equivalent to this. And there it is. Yep, this is it. It's strictly greater than, so it's just a comma. Strictly less than, so it's just parentheses. Parentheses. And I call them soft bracket. These we call hard brackets parentheses, and we call these soft bracket parentheses. So the nice little curly one is a soft bracket. The equality one is the hard bracket. That's how they kind of differentiate them. Oh man, set notation. I don't know. I don't think I'm gonna ask you much set, but it's algebra. You'll need this later on. They'll give you a problem that really kind of set up as in that case. This line means such that. This said the set of x's. That's it. And this says such that x is greater than or equal to 2. The set, and then the set is what they talk about. They talk about x. The slash just means such that is shorthand in math. Such that x is greater or equal to 2. The vertical line reads such that. They didn't use a symbol. It means the element. And they usually say this is an element in the set. The way they use that element, I would have wrote this different. So here's the set. X is greater than -2, greater than 2. Here's how you write this in the soft bracket. X is hard bracket at 2. And it doesn't stop because it's greater than 2. It doesn't stop. It goes to infinity. Infinity is always a soft bracket. Infinity is a soft bracket because we're never at infinity. Infinity is always moving. So it always gets a soft bracket. Everything, you're never at infinity. This is the same. I'm writing the example in this interval notation. This would be x, and they'll say x is an element in this set. This is the symbol. X is an element in the set. It reads the same thing as this example down here. They're saying the same exact thing. And usually we leave out x as an element. They assume you know that part and they just write the interval. I'm showing it so when you see it, you understand. But anytime I ask question, you're just going to put the interval. But no, this was the true form. X is an element in this set. As this one, x such that x is greater or equal to 2. Same exact thing, just look different forms of notation, interval notation, set notation. All right, blah, blah, blah. So all the new stuff that's coming up. All right, here's some example. This is like a two-step equation. This is a two-step equation. You can still check if things is a solution. So here they say, is X a solution? They plug it in. And look, they got -2 made 1 on this side. When I put -2 in, X equal to -2 in our test, you say, yes, look, -2 is less than 16. So yes, it's a solution because it makes this true. It makes this statement true. Whatever over here must make sure it's less than 16. So as long as I put in a number, and when I plug the number in, I'm less than this other side, it's a solution. And again, it's many solution. You saw that it's interval of solution. Once we see inequality, it's not one number anymore. It's a set of numbers. It's a set of numbers. We talked about that. They talk questions tend to come as this. And it's actually 2 separate inequality we're doing in one shot. It's 2 separate inequality. We have the lower half and you have the upper half. They just do it in one for the mathematics. It's 2 separate, and actually, here we go, right here. They did the lower half right here, and they doing that part. It's an and case. It's an and case. It's an intersection. So how we do it, they say just put it together, and whatever we do on one side, we do on the other. So they look at this and they say, first we want to get rid of the 5. I'm a -5 on both sides. But remember, I'm not just minusing 5 on the right. I'm minusing 5 on the left because I got 2 separate equations. It's 2 separate equations I'm working with. So on the left side becomes -8 On the right side, it becomes 12. 17 minus 5 is 12. Negative minus 5, 3 is negative 8. And this one, 2x plus 5 minus 5 is 2x in the middle. See that? One step down. Let's do the next step. Then we're going to divide by 2. When we divide by 2, the outside becomes 6, and the other side becomes negative 4. Yes, I'm going to put something like this on the quiz next week. So knowing that it's soft bracket, it's strictly greater, and it's not at 4. They use negative 4 and comma 6. This is not the XY coordinate, because we do that, people start confusing this. This is not the XY coordinate. Not. This is a starting point on the number line. This is the end point on the number line. That's what this means. It's not the XY coordinate. Don't confuse them. It's written similar. Okay, it's not the XY coordinate. If I had an equality here, say right here, 6 was equal, then this problem would have been negative 4 with the soft bracket, and the hard bracket would be on 6 for the equality. This, you tend to know this from jump. You know it from the question being asked. They'll tell you from here if you're going to have soft bracket or hard brackets. You'll know from the question. All right, that's inequalities. And yeah, I feel better. I missed a couple of these. I didn't get to do that earlier today either. You guys are a little bit quiet, so sometimes I'm worried if you're listening. The ones in the day, I'm worried.
Here.
Okay, thank you. Thank you. All right, so I think I finished everything I wanted to touch base with you guys, except the geometric questions. I did not do a geometric question. I'll answer one from the problem set. And as I say, I don't know if I'll put them in. But I pretty much said everything I wanted to say in terms of the PowerPoint presentation, in terms of the notes. Let me make this a little bit larger. I gotta try to get those information to Sue as soon as possible. Again, doing something like this will cancel the fraction. We actually did see that multiplying by 15, and you're gonna get 5x plus 3 equal to 3x minus 15, whatever. We did this system of equation that you could work it out. So all these, after what I went over, do these. And any questions you have not being able to complete this notes, you will ask me then. Because I didn't do much writing, but I was going over this material in the just now from the PowerPoint. This is one thing I wanted to say. I didn't get to go over many of these. The word problem. You have to kind of decipher 4 or less. They like to use that a lot because they use the one that people have trouble the most. 4 or less, people want to say 4 minus something. 4 less than twice some number is 16. It's almost right, but it's wrong. This is how I see a lot of students doing this problem because the 4 is in front. 4 less, meaning we need a minus 4. 4 less mean we need a minus 4. Less than twice the number. So twice the number is 2x. And take away 4 is 4 less than twice that number, and that's equal to 16. That's the way you have to envision that problem. 4 less is a negative 4. Then twice a number. That's again, and once you set this problem up, we can solve it. That's a word problem that turns into a nice 2-step problem. We first add 4 to each side and divide by 2. Add 4 to get 2x equals to 20. Divide by 2, x equals 10. When I do these problems, you write this out. You should complete this yourself. Even though you hear me talking, once I put something like this down, you should write what x is equal to. And if you don't know how to do it, then you say, "Oh, Mr. Ferg, you mind working that out? Because I was trying to get them stuck or whatever." But I'm not going to do all these problems. It's impossible. If I show you everything, I can't get through the set or the curriculum. And I feel bad because again, it's a lot. It's a lot. But it's school is designed like that. I don't know who came up with it. It's the fastest learners. You know, they have to make it competitive. And what just happened? Did I get cut off? Oh, thank you. All right. When 7 is subtracted from 3 times the sum of a number and 12, the result is 20. I'm not going to ask you this, but actually I can. You should work them out on the homework. I just want to go over an example. When 7 is subtracted from 3 times the sum. So let's break this down. It's a nested problem. Something is being subtracted from something. Remember, that's a trick question again. They put 7 in the front because it won't mess you up. 7 is taken away from them. So we got to get what's taken away from what? Taken away from 3 times the sum. The sum of what? The sum of a number and 12. That's the first thing. The sum of a number and 12 is x plus 12. That's the first thing. So I had to look into this problem and break it down from the nested, meaning like I'm starting from the back to the front, but it's really the nest. I'm going inside the parentheses first. So number and 12, and that's the sum. But we want what? They say 3 times the sum. 3 times the sum. So 3 times the sum. And it's 7 is subtracted from 3 times the sum. 7 is subtracted from 3 times the sum. The result is 20. That means it equals to 20. That's kind of involved. I'm not going to test you on that, right? I'm giving you the basic 2 steps and some multi-steps to bring down. But the fact that this is here, that means you're supposed to know how to do it. If I do ask a question, it'll look more like the first one on your quiz. But it's something to know. You should really know the setup. And like I write this problem again, you should solve this. I'm not solving it. You should say, you know what? I'm going to group the like term, which is going to be 36 minus 7, make it 29. And I'm going to take it to the other side. Minus 29. A positive 29 becomes a minus 29. This looks like it's going to be a minus 9 on one side. 3x minus 9, the answer's going to be minus 3. I'm sorry, I did all that in my head. You should write it out. X is minus 3. Let's test it. Minus 3 times minus 3 plus 12 is a 9. 3 times 9 is 27. 27 minus 7 is 20. All right. More of those problems. Read through this and try to finish this. Whatever questions you have, we could talk about it. But go through the notes. Here's a geometric question. It's a nice question to ask on a test, but I don't know how to do this. So because everything is W, a perimeter means we add up all the sides. You're leaving? What time is it? Is it time to go? Let me check the clock.
9:14.
Yeah, I got 12 minutes. I'm sorry, I'm giving you your money's worth. Remember, you don't got to drive home. You're already home. I'm hoping, or at work. But either way, commute is not an issue. You know, I'll be running out the building now to try and press gas. So, all right, here we go. These are the perimeters until you add up all the length. Remember, this is a parallelogram, and whatever this length is, the other length is the same. They're equal length. So 3x plus 4 on one side, the other side is 3x plus 4. W on one side, the other one is W. I mean 3W, not 3x. So how do we add it up? They say the perimeter is 2 times the length. I can write 2 times the length, or I can just pretty much write everything. I could do 2 times the length, or I could just write out what 2 times mean. 2 times is the number. We add the number twice. Then we add W plus W. Now let's add up all the W's. 3 W's plus 3 W's is 6 W's plus one more W is 7 W plus another W. That looks like 8 W's. 8 W's right there. And I didn't even look at the question. What was the question? The perimeter question. So I'm thinking it's like just tell you what the perimeter is. The only thing we can do is simplify. 4 plus 4 is 8. So that is the perimeter of this. That's the formula to get the perimeter. If you tell me what the length of the width is, I can tell you what the perimeter is. So you have your property and you want to know what's the distance around the property. And say as long as you know one side of the property, you could know everything, the total. Like you're gonna buy some fence. I said just measure one side and we know how much fence to buy. It's efficient in that way. Same thing with this perimeter. Same deal. We'll add up all the x for perimeter, x plus 7 plus 5x, and then we see 3x plus 12. When we're done the perimeter, when we add up all of this, I see 3x plus 12. Again, I'm sorry, I'm doing too many of your problems, but you should see them in your, whatever I don't do, you should see in your on the test, maybe. Like the questions, the homework question from the previous. They want you to do either or. This is the or case, is the outside. X is less than 3. X is less than 3. Is going this way. And it's not there. X is greater than 6. And we always read from the X, even if it's written the other way. X is greater than 6, but X is also equal to 6. When X is equal to 6, that is that. X equal to 6 is a point. X greater than 6 now would be the boom. So all the interval except for right here satisfy X. This will not make this true. So if I put 4, 4 is not a solution because 4 does make this is not true. 4 is not less than 3 and 4 is not greater than 6. So 4 is not in the solution. See, the solution, anything going this way or any number going that way is in the solution. 5 is not in the solution set. 5 is not in the solution of that inequality. What does that mean? 5 will not satisfy the statement either. Same way 4 didn't, 5 wouldn't. 5 is not less than 3. 5 is no good. 5 is not greater than 6. 5 is no good. So the numbers in between here are no good. The solution set is on the outside. And notice we put the dot, this one is a shaded dot, and the arrows go all the way in. I'll put an arrow on it because it's going off to infinity. Every number going all the way to infinity will make this true. Same thing, every number going to negative infinity will satisfy these. All right, I think I talked enough. Wrote. What else I have to say? Yeah, that is it. Interval notation. So in the check case, look at this. -2 a solution. 3 times -2 is -6. Yes, we did do that one. What about 4? Is 4 of a solution? I don't think so. 3 times 4 is 12. 12 plus 7. 12 plus 7 is 19. 19 is not less than 3, so X is not a solution. 2 is a solution. -2 is a solution. -2 makes this true. When I put -2 in, it says 1 less than 16. 1 is less than 16, so -2 is a part of the solution. When I put 4 in, it tells me this, the left side is 19, and 19 is not less than 16. So therefore, this doesn't make sense. Some inconsistency, contradiction, whatever. It's not true. So that's us testing it. And you know how to solve it? You solve like you solve in a regular two-step equation. That's how you solve these. You solve just like a simple equation. To solve for this, I'm a -7 on both sides. And 3x is less than 15. X is less than 5. So as long as x is less than 5, hold on. So that means that should be right then. 4 should work. Hold on. That should -7. Oh, this is supposed to be a -7. I'm sorry. This is 11. It's my fault. It's 11. Okay. Yeah, 4 doesn't work. So x is less than 11 divided by 3. 11 divided by 3. 11 divided by 3 is about it's 3 2/3. So 4 is definitely too big. 4 is not in the set because it's less than 3 2/3. All the things that's going to make this true must be less than 3 2/3. Anything that's less than, so x is less than 3.666666. That's what that means. X is less than 3/11. So therefore, 4 is not in the set because x is 4, meaning 4 is less than 3 and change, and that's not true. 4 is not less than 3 2/3. So that means it's not true. 4 is not in the set. That's really what this is. Everything we do is to test the numbers that you get. When I test the number, is the statement true? That's what it means to be a solution. 10 o'clock almost. And maybe, I think I'm done with this. The most I may want to do is, yeah, we're done. And I'm glad I completed this. Perfect. I'll post this video.
Thank you.
The only thing I didn't do here is the questions. Where are they? These things. That we won't do. We did that already. So that's, we're going to skip that. Maybe I put them this, maybe one of these. Again, the best way to do is multiply by the LCD instead of doing anything and make it a nice number. So what's the LCD here? This would be 12. If you multiply every term by 12, you'll see how nice it gets. It'll be 6. If I multiply a half by 12, I get 6. If I multiply 2/3 by 12, I get 8. And if I multiply a quarter by 12, I get 3x. 3x plus 8 equal to 6. If you multiply everything by 12, this becomes 3x plus 8 equal to 6. That's a nice two-step. So do it yourself to see it work out. Yes, this is the one I wanted to say. So the ones we saw first, you've been done, you knew how to do it. This is where we're going next. Cross multiply. We're going to still apply that cross product. This negative everything. This is so ugly. I'm going to do this as -2 because of that negative times 5. Actually, I'm gonna not do the -2. I'm gonna just do 2. I want my positive number over here. That's why I'm doing it. 2 times 5 n minus 1, and that's equal to, I'm gonna do this cross multiplying, -3. I'll put the negative on that side. -3 times 2n. That's the first step. And if you see the first step, we say that looks like it's 10n minus 2 equal to -6n. So now what I'm going to do, I'm going to move 6n to this side and move 2 to that side. I'm going to move 6n over. That means I got to add 6n on both sides. Actually, put it underneath the n. I'm going to add 6n plus. And then I'm going to take away 2. I want the numbers on one side and the n on the other, and add them up. So when I reduce this looks like I have 16x on one side, 16n, I keep saying x, 16x is equal to, this is 0 minus 2, -2. Or this looks like n is equal to -2 over 16. That should be able to read that answer correct, because it's a calculator. This should be able to count. And I can simplify this to 1 over 8. 2 into 16 is 8. -1, 8. So the answer looks like -1 over 8. Check and answer. And it's wrong. Hold on. What did I do wrong? Oh, here's what I did wrong. Right here, the cross multiplying. It's not wrong. 3 times 2 is -6n, right? -6n. Give me a second. 2.
I got it right when I just put in 1 over 8.
Okay, I see. What's the mistake right here? It's 1, right? It's the minus. Look at this. If I -2 and I -2, what this becomes? -4. -4. It didn't become right. That's an error right there. So this is supposed to be a positive number. This is supposed to be a +2. You see it? If I minus and I minus, I didn't make it 16 and 0. This did not become 0. It'd be 16 and -4. Right? So I had to make this a positive. Well, that's wrong. And what do I need? I need this. It's a positive. I need a positive to cancel out this. Minus and -2 would make it a -4, which can't be. I need it to be 0. So I'll check, and this means this is supposed to be a positive and a positive. Therefore, this is a positive 1/8. And that's why you say the positive 1/8 will work. So simplicity, let's see if it can do it with, say, 2 divided by 16, and see if it likes that. It does like that. So it doesn't mind if you reduce or not in terms of the homework. And I'm going to put the simplest form. Okay. All right. I think that's pretty much the stuff I wanted to show. You guys actually did get through the lesson. Everything else you got to kind of practice, and it is a lot of information. Go through the notes, try to be able to do all the notes yourself, and just go through the homework questions the same. So the notes for your hand, just write about, and then the online, because many of you told me you finished the online from early. You did it from the last time out. Hopefully it lets you go back and do the ones you got incorrect, and you could make sure everything is answered correctly. You might lose some points, because I think they lose points each attempt, but to have everything answered correctly, I think hold more weight. Right. Likely these questions, this you can still cross multiply. Or guess what? We could multiply by the LCD. The same one we could cross multiply, like I just showed you, or I can multiply by the LCD, which is 6. This side times 6. 6 times this 3, this becomes 10. 6 times this becomes 3, because the 2 going to divide the 6. It becomes 3 times 3 and minus 1. Well, I guess it's just the same as we cross multiply. 2 times 5 is 10, and then 3 times that. That's the same as multiplying with the LCD. Similar. So whichever approach, math is math, whichever technique you take or use. I just say make sure you do the way you're comfortable. Do the method you're most comfortable and sure of. Even if I show you a method and you have your method sealed up, you do it your way as long as you know you can get it right. This is not to find where I'm going. This is the way I'm going. However, that being said, you should not put a block on new techniques and new methodology. I always tell the students, it's like, you can build a house with a load of hammer and a nail and a hand tool. And yeah, you're going to probably take some time and hard work. But if I show you to use some power tools and you have the electric saw, the drill, and, the power, the air gun, you're going to build much quicker with less work and less effort. So that's all I'm saying. Learn new technology in terms of the math. I would say that's like the new technique, how to knock out the problems that you're known from before, you're familiar with. All right. That being said, I think I'm going to stop sharing my screen. If you have a question, let me know. Will the test be graded? When will the test be? It's corrected already. You could run your I don't remember how you go for your grades, but someone said if you go in there now and run your report, run the grades, it should show. If it's 100%, it should show that. Once I did that adjust score, I did it right there in class. I hit save. It was already updated. It's just for you to update your grade. So you have to like run your server for your grades or request your grades again or whatever you have to do through Educasoft. I don't know how to do it. I never done it. So I can't tell you what to do. I know a couple students might know. All right. Good night, guys. Yep. And where is my...
Good night. Thank
Good
you.
night.
Thank you. Good night.
All right. That's out. Let's go.